Hello guys. So in the series of discussion of queen theory, now I'm going to discuss concept in model number 3 in queen theory. So in first one we see that the number of server are taken only one and the capacity of that one is taken as infinite. In model number 2 we have already discussed that the number of server will be 1 and the capacity is equal to k, and now in this I am going to discuss that number of server will be m or s and the capacity will as infinite. So here the presentation is like m s gd infinite and infinite, where m and m represent the arrival and dispatcher distribution in Markov process, and s is the number of server. We can also represent like m. Okay, so capacity is infinite and this one is population size will also be infinite. So this is the simple representation in model number 3 I have taken. So now what are the different formulas involved in this and how we proceed to solve the question in model number 3. So here are some concepts involved in model number 3, like if we talk in the terms of probability for zeroth distribution. So P naught is equal to summation of n is equal to 0 to n s is equal to 1, and this is s and this is rho inside that in to the power n and divided by n factorial plus s to the power s divided by s factorial multiplication with rho to the power s divided by 1 minus rho, and this whole and multiplication with this term, and this is the in inverse form, that is 1 minus 1. Okay, where rho is nothing but lambda upon s multiplication with mu. S is number of server. Now if we talk in the terms of nth term, what will be the nth term of p? So it will be like this one. Okay, so here the one thing we have to note that here from n is equal to 0 to n is equal to s minus 1, the distribution is like this one, 1 upon n factorial, and like this one. Okay, and when we talk when the distribution is like from n is equal to s to the s plus 1 and so on, then the distribution is like this one, 1 upon s factorial, and this one like. Okay, so this is important thing we have to remember this one. Okay, now what are the measures in model number 3? Like what are the simple things in model number 3, like length of queue, what is the waiting time in the queue, what is the waiting time in system, what is the length of system, what is the length of queue, like that. So what formula we use in model number 3? So here LQ is equal to rho multiplication with s. S is nothing but number of server and multiplication with rho to the whole power s and divide by rho factorial, s factorial, and multiplication with 1 minus rho to the whole square, and here nothing, p naught is simple as ps and multiplication with rho divided by 1 minus rho square. And here second formula for length in system is equal to LQ, length of Q, plus lambda upon mu. Okay, and now what is WQ? WQ is nothing but waiting time in Q, that is lambda upon L by LQ divided by lambda, and this is equal to rho of S multiplication with 1 upon S into mu multiplication with 1 minus rho to the power square. Okay, so this is. Now what is WS? WS is equal to lambda upon S. Lambda S divided by lambda is equal to lambda Q plus 1 by rho. So these are the simple terminologies we have taken here in model number 3. So this is the simple concept involved in model number 3. Just go through it. And now here some more things also I want to discuss, that waiting time distribution. Sometimes it is simple about to distribution in waiting time distribution. So for that you have to follow this simple approach. Probability that t is greater than t, where t is nothing but, this is like, we can say this is a random variable like that, or uh, a random variable to measure success rate, and likewise. So it is equal to e to the power mu into t and whole multiplication with this term. So be carefully to look in it. And now, what is the probability distribution of busy period? Like in system, how many time server or uh, service provider is goes to busy, we have to find out that distribution. So here, probability that time is greater than 0, it is nothing but ps divided by 1 by rho, where ps is this one. Here lambda upon mu is written here to the power lambda, and multiplication with p naught and divided by s factorial. Okay, and now these two term is our waiting time distribution and probability distribution. Now that if we have to find out the efficiency of model, okay, like what is the efficiency of MMS model? So for that we have to use simple formula, that is average number of customer in the server divided by total number of customer in the server. So by using this we can simply get what is the efficiency of model our. So these are the simple concept or simple terminology, simple formulas we are required to use in our model. So just look on it and note it in one page and be happy. And thank you very much for watching this video.